And the third section of the IoV is the solution. The solution, we have some requirement of the network. Let us see first. These are the application scenarios. Some are for the proactive security or safety. Some is for automated driving. They have a different requirement of the network. This one can be level 1, 2, or level 3. And this one will be level 4 and level 5. Okay? Different level of the automation, automated driving. Level 1, level 2, level 3, 4, and 5, they have a different requirement to the network. For the network solution, of course, we need to see the requirement. Level 1, level 2 is not related to the automation. Okay, so they do not need too much bandwidth. They do not need too much of the delay time. Here, RTT means round trip time. Okay, round trip time. No, it's just a delay. Level 3 is conditional automation. You can see that the throughput and the delay. It has the requirement. Okay. Level 4 and 5, throughput very high. Delay very short. This we need 5G to support. And for the operator, how can the mobile operator come into this business? We can say that the IoV solution, we need 5G. For 5G, of course, mobile operator will come into the playground. The operator can step into the IoV business in 3 levels. The first level is the operator will just provide connection. It's very normal. Our operator nowadays are just providing connections. We say pipe, okay? Providing a pipe. Just 4G or 5G coverage, and their core network also. Okay, and the platform and the application will be deployed by third party. Okay. So this is a very common case. The operator will just provide connections, okay, as normal. The second level is that the mobile operator can provide not only connection, but also a platform. This platform can enable the big data storage, big data analysis, and it can provide you the environment to deploy the service application. Okay. So this is the second level of the operator to step into the IoV business. Also possible. And the third level will be the mobile operator can provide not only connection, platform, but also the service. That is to say that this operator can provide end-to-end solution for the IoV. I think this will be very hard for the mobile operator to realize because the industry chain first is very long. Second is the mobile operator actually is not very familiar with this industry. It's very hard for this. The first or second, these 2 degrees is possible, right? Okay. And of course, for the CV2X or IoT, we need the IT infrastructure, okay, ICT infrastructure to support. Okay. We need the network communication. Okay. We need the device. We need the chipset. Okay. Cloud computing and the big data and AI. Now these technologies needed, okay, to form one IoV network. And of course, the vehicles and our road will be equipped with intelligent devices also. In the vehicle, we have OBU, okay, and on the road, we have RSU. And with these devices and a network, it can make our transportation more safe, okay, more efficient, okay, with this intelligent transportation system, and more convenient, even can be smart driving or automated driving. So the IoV solution is to form the IoV network, we need our vehicles with the terminal. with the T box or OBU at the onboard unit. Okay. Of course, the vehicle should have one unit inside it. Okay. Now you will call it OBU, onboard. That's in the car. Okay. In the vehicle, onboard unit. This onboard unit may be communicating with 4G or 5G. No. And IVI is just for some information. Okay. In vehicle information or entertainment. You want to listen to some video, listen to some music, watch some video. Okay, this one. And in vehicle computing platform, MDC. This MDC is a small computer, okay? Mobile digital computer, MDC. Is for computing. So this is what's inside of the vehicle. Okay. And not only the vehicle should be equipped with devices, our road should also be intelligent. Our road will be equipped with a roadside unit, okay, RSS camera and radar, okay. This the roadside. We call it infrastructure, okay, infrastructure. And our network, we need at least a 4G network for basic scenarios, and for advanced scenarios, we need 5G, right? Okay, 4G or 5G C-V2X network. And we need a platform. This platform can enable different services. Okay. IoV platform installed on V2X server, okay, and IVI service. Okay, IVI just for this IVI, video, audio, okay, entertainment, or some information. Okay, and this is for V2X. This is a V2X server with exchange information between vehicles or between the vehicle and our infrastructure. And upon this platform, here are the content supported. TSP, SP, CP, these are content of service or content provider. Content. For example, the IoV, okay, IoV provided can be TSP or SP, okay, CP provider, service provider. Payment, music, okay, HD maps, and more important, ITS. ITS means intelligent transportation system. Intelligent transportation system. And this can send some very important information to the vehicles or to the roadside for the dynamic map. Okay. They may have dynamic scheduling, dynamic adjustment for some traffic light. So I think all this abbreviation is very clear. So these are to have one IoV network, we need to have such solutions. So that is why we can say that this is not an easy job, because the industry chain is very long. Many kinds of vendors or manufacturers are related, and they need the cooperation with each other. We just mentioned the ITS. ITS means Intelligent Transportation System, right? Let's see how this ITS work. First, let's have a look at the gray color part. The gray color is just the road. On the road, there are vehicles. These vehicles will be installed with some unit, OBU, onboard unit. Okay. This onboard unit, it has a module or chipset inside. It's just for the communication. Okay. And this can enable the vehicle communicate with each other. And it can also enable the vehicle communicate with the infrastructure. Okay. On the road, there is infrastructure. This is RSU, the camera. And it can also communicate with the pedestrian, with person. So this communication V2V, V2I, V2P, okay, and a V2N. So this communication realized by this onboard unit. This part is clear. And we need a network. This network can be LTE or 5G. Currently, LTE. In the future, 5G. Okay, 5G V2X. With this network communicate with this V2X server. Of course, in the middle, it should travel through the mobile network, okay, 5G or 4G to this V2X server. This V2X server should be installed with different applications, okay, and the ITS is just one of these applications. This application is for the intelligent transportation. Okay, intelligent transportation. For what? It can improve the driving safety. Okay. For example, this car detects there are some obstacle here. Okay, and it can send this information to the car after it. Okay. And maybe they cannot communicate directly. Then this information can be sent to the ITS system. The ITS system will send it through the network to this car. Got it? This information exchange, okay, it can make the safety, okay, more safe, and it can improve the traffic efficiency. For example, our roadside unit can detect the traffic flow and adjust the traffic light to make this passing through more efficient. You can feel that a lot of time we stop our car, okay, in front of the traffic light, just waiting, and the other road there's no traffic, and we have to wait for the red light, right? So in this case, this traffic light indication is of low efficiency. Okay? If we can adjust the traffic light according to the traffic flow, it can enhance the efficiency, right? Okay, so it can improve the traffic efficiency, and it can enable the cooperative automated driving in the future. And this may enable the cooperative automatic driving. All the car sensors, they can share the information from this network, okay, and this can facilitate the automatic driving. Okay. So this is about the ITS, okay, ITS system. And now commercially available solutions. Here we have some chipset available. This page shows us Huawei product for CV2X. Huawei has Balong 765. This is based on 3GPP release 14. Based on first chipset supporting CV2X, world first, okay, supporting CV2X release 14. OBU, the T-box, RSU, and also a V2X server. And we have server, a layered structure, and it can support third-party algorithm deployment. So these are some products from Huawei to support the CV2X. The intelligent transportation platform, in fact, it's just IT. Just previous page we call it ITS, okay, ITS, Intelligent Transportation System. Here we have a lot of infrastructure, like camera, radar, traffic light, and a bridge or tunnel supervision, also some cameras. We can collect a lot of data from our road, okay, and collect the data, and then this data can be sent through the network to the intelligent transportation platform. Okay. This intelligent transportation platform will process the data, and it can make some optimized decision. Okay. And they can send the decision, send it to the traffic light. They can also send it to other vehicles to coordinate the traffic. So we can say our infrastructure as the input, and this processing and processed, there is a decision, okay, decision sent then to the vehicle or traffic light, okay, to adjust the traffic, make this more efficient. The ITS system development, we will follow 3 phases because this job is not a one-time job, step by step, phase by phase. For the first phase is, we call it a single static scenario. See, this is a very typical example. We have video surveillance cameras everywhere, especially now in China. We have this a lot. And the traffic guide board is static, to paint it. Okay, it's electric. Okay. It's statically painted. And the traffic light also not intelligent, just a fixed algorithm. Sometime based on time. Okay, let's say 1 minute red light, 1 minute green light, like this. Okay. This is the most of the case. Okay, in some small cities, and in some more advanced cities now is in phase 2. Phase 2 is a semi-automatic, single semi-automatic. We can collect the traffic using the camera, and our ITS system can analyze this traffic and adjust the traffic light with the optimized traffic light. This is already realized in some places in China. Some traffic light is already intelligent. Okay, so now we are at phase 2. We hope we will go to phase 3. In phase 3 that is fully intelligent. That the V2V, V2I, V2A network using edge computing 5G, okay, realized. We can even realize automatic driving in this case, okay, in the phase 3. Okay. Now we are at phase 2, and in the future we will step to phase 3, maybe after the year of 2025. And this page again shows us the C-V2X component. This vehicle equipped with a onboard unit. It can support IVI, okay, for entertainment. V2N to network, V2 person, V2 pedestrian, V2V, V2I communication, and with 5G, okay, to realize this can provide a seamless connection, 5G coverage, okay, seamless connection, low latency, high reliability, and smart connection. Okay, this 5G V2X. And 5G V2X can support all advanced automated driving. 4 scenarios. So we have mentioned that these 4 scenarios in the previous slide already. 4 scenarios: platooning, cooperative automated driving, remote driving, and advanced driving. And they have different requirements to the network: latency, reliability, and throughput. Now, all of these, they have high requirement for the network. They need very low latency, and they need very high reliability, and they need broad bandwidth with the throughput. Okay. And only 5G can provide such performance. 5G for 4G is cannot satisfy this requirement. And for 5G, we have some innovations, more advanced technique introduced, so it can provide better performance over the network. First is about the architecture. Our 5G can support slicing, so we can have a URLC slice, we can have a EMBB slice, right? Slicing. The slicing can provide us end-to-end QoS. The key here, QoS means quality of service. Okay. And convergence. Our 5G can coexist with 4G, LTE-V. LTE-V means LTE V2X. And a 5G V2X can also coexist with the DSRC, even can cooperate with DSRC. Okay. So the convergence means coexistence. And 5G UU interface enhanced. It supports unicast and multicast. Unicast means point to point. Multicast means point to multiple points. Ultra reliable and low latency. And user-centric no-cell radio access, UCNC. This is the one feature of handover. This can make handover more smooth, even no need for handover when the vehicle is passing through different cells. And dual connectivity, the terminal can have more than one connection to the network. Spectrum, the side link can use licensed or unlicensed frequencies. So side link means the connection between vehicles. Just a V2V, a V2V connection is also called a side link. Okay, vehicle to vehicle connection, also called a side link. And this side link can use licensed frequency, just a 5G frequency, and it can also use the unlicensed, for example, the public frequency can also be used. And the positioning, for the positioning, it can support a UU interface based. UU interface is just the interface between the base station and the terminal. This air interface is UU interface, user interface. Okay. We know that the positioning can be from a satellite, GPS or BDS satellite for positioning. And to make the position more accurate, more precise, this position can be aided by the UU interface. Because the base stations have their longitude and latitude fixed. They can assist for more accuracy for the positioning. Okay. And also for side link based positioning. Now, side link between vehicles, okay, connection can also help to make the positioning more accurate. Okay. It can be even to sub-meter level. The accuracy can be even less than 1 meter of the positioning. So these are some innovation advanced points for 5G V2X. And we mentioned the side link, and this page tells us the 5G side link and the UU enhancement. 5G side link, this is a side link between cars, okay, cars. So they can communicate through the network, or they can communicate directly, the side link. And the side link can support the relay function. For example, this car is out of the coverage range of 5G base station. Okay, this car out of the coverage range. And this car can communicate with the vehicle which is inside the coverage. And then they communicate with our network. So we call this function as relay, a relay function. And the side link based positioning. With a satellite for positioning and the car can help to make the positioning more accurate, more precise. Okay, that's about 5G side link and the UU enhancement. UCNC, you see this is one cell, this is another cell. Then this handover can enable this advanced UCNC. It make the seamless handover. Actually, no handover needed. This can guarantee the better experience for the user. And flexible multicast, especially for the high definition map download. It can support point to multiple point communication. That it can enhance the efficiency for this lot of cars downloading the map at the same time. Then we can just download one time. No need to download 5 times for 5 cars. It is multicast, higher efficiency. And also, no matter for UU interface or for side link, no matter for which one, we have the unified QoS guarantee.